Another way we can organize our code is using something called a class. And actually, to start, we kind of have to speak somewhat abstractly about this concept initially. So I think probably the best way is to diagram this out. So I'm going to use Lucidcharts, and we're going to use something called Unified Modeling Language to diagram this. And basically what UML is writing a bunch of boxes to kind of show what the different objects in our code is. So let's see. I believe we can go look under Lucidcharts. You can find visualize technical systems, and you can go to UML class. So this one right here is actually the one that we as programmers use. There's a bunch of other types of diagramming that's used in programming and networking and database design. So they're all here. Almost all of these are really just box charts with arrows between them. So, but this is the one that we programmers often use for object-oriented programming. We'll let this load up. And I'm going to delete almost all of this, or actually all of this, and just start very simply. And initially I'm just going to write some things out on here. So let me just, can I put some text on here? There we go. So let's just think about, let's say that we were going to make a system to keep track of the inventory in a warehouse. And so we're going to make a class, and you will understand that term a little bit later, that will be used to keep track of the information needed for each inventory item and the methods or functions that we're going to do with those items. And really what a class is just a collection of data elements and functions or methods that are called methods. So let's just say we have inventory item. And we wanted to know, and then just think about what sorts of things, if we have an item in inventory, what sorts of things would we keep track of for an inventory item? Well, we would probably want to know its location. Maybe its serial number, make, and model. What other things might we keep track of for an inventory item? Maybe the date in and the date out. And maybe with the date out, you know, null means still in inventory. So, you know, there's some pretty common things. And if you run through this exercise, just write down all the things that you could think of, keep track of. That would, you know, you'd come up with a very long list, typically. And we're going to call these things attributes for now. Or actually we can, and you can even think of them as properties. We're going to use attributes because it's a generic non-programming term. Properties actually mean something from a programming perspective. So let's just think of these for now as attributes. They are descriptors of this inventory item. In point of fact, we could have many inventory items, and each inventory item will have likely be in a different location, will have a different serial number, different make, model, date in, and date out. But all inventory items will have these attributes. And then methods. What could we be able to do with this? So, what functions would we need to execute with our program when this comes in? So if we think about, we could think of this as what's often called a use case, which is think about this object and its life cycle and what happens with it. Add to inventory. So when it first comes into the warehouse, we probably need a method to add to inventory. And I'm putting parentheses after these to specify that these are methods, these are functions. Remove from inventory. Move. We need, and when we move it, we would, need a new location probably. And when we add it to inventory, what would we need? We would need to specify the date it came into inventory, and then we would, let's make these look more variable-like. It makes it easier to see. We would need the date out, right? And that would probably be the fundamentals of that. And so we can already go ahead and make these into function names, or things that look more like our function names. And then maybe we'll make these look like it's not critical at this stage. We're just diagramming, but not bad to, because then we kind of have C. So here's what so if we're writing code for this inventory item, we would have pretty much what we need. We have our variables. And if you think about it, when you add it to inventory, what else do you need to know? We might probably need to know location. And, so now we're getting a little better picture of what our program's looking like. If you think about it, this is what I'm going to keep track of. And these are things I'm going to write functions for. And that's pretty useful. So how do we do this with a UML diagram? Well, we can actually, I'm going to move this to the side a little bit. And here is a standard UML diagram object. Let me reduce, make this a little bit smaller. So this is the work we did here, and then we can bring this up. Okay, so, well, this is actually, we just did a UML model because basically you and then they have some boilerplate here for variables. Notice they have, this is written for other languages where we worry about the typing. We don't need that here, so we're just going to keep this simple. The plus and the minus means public or private. We will get into describe that. So for now, we can just basically take this list of attributes, and we'll just put that here. So location, serial number, make, model, date in, and date out. And normally when we're doing this, we don't go through the process of writing it out and then put it in here. We just put it in here. But I wanted to kind of show you the thought process. And then here are our methods. And I think if I put a space in here, it's easier to see which one is which. So that's our UML model of the class we're going to make. So we don't really need this anymore. We have a UML model, and it's basically the same thing. At the top of your UML model, you put in the name of your class, then you list the attributes you need and for this class, and then you write out what things you want to do with it. And now we can make a program out of this. And we're going to kind of formulaically write this this program, and we'll see that all we're really doing is, rather than having all the variables for all the things in our program all in one big space and having all the functions kind of mishmashed all over the place, we are saying, let's put all the things associated with inventory item into one little package and make it nice and concise. That way we don't have to chase our code all over the place. So that is how we conceive of a class. A class is a collection of attributes stored as variables and function or methods, which are functions associated with a class. That is basically what a class is, and it helps us to divide up our code, and we'll better understand that when we start actually writing code with these. Thank you.